Let's have a look at the syllabus once again. Asks you to compare and contrast the differences in transmission media. Let's do that by looking at the various sources of error. We've been through every one. You know what each one is. Heat. As you heat up a copper wire, it has more resistance, which then induces higher attenuation, higher thermal fluctuation in the cable and less reliable transmission. So cable is affected by heat. Wireless, the lighter the air, the quicker the, or the more you heat up the air, the lighter it becomes, the faster the signal transmits through it. However, the changes in heat tend to deflect the signal through refraction. So yes, heat affects wireless. These are the common forms of error in the signal. Does heat affect infrared? Absolutely, heat is infrared. If you have an infrared signal that's exposed to a source of heat, then it's completely clouded. Microwaves, same reason, the air tends to deflect them. Fibre optics aren't really affected by heat, the light just transmits through anyway. So fibre optic is the perfect case for areas where you've got thermal fluctuation. Impulse noise, like a thunderstorm. AM radio is massively affected by a thunderstorm. We're going to do a quick video on noise in a second, but that is a problem. Cables pick up the same electrical signal. A cable is an aerial. If there's a thunderstorm outside, then the cable is picking up the electrical signal. Infrared isn't really affected by impulse noise. Microwaves. Microwaves produce a lot of impulse noise. They're 2.4 gigs, so I'll put a single tick. If I could do a half tick, I'd do that. Fibre optics are not affected by electromagnetic fluctuation. They're perfect for applications where that's where there's a highly charged electrical field or a highly changing magnetic field or radio waves. Use fibre optics and you don't have interference. Attenuation, loss in signal strength. Cables are dramatically affected. Wireless, I'm going to give it 3 ticks. Wireless tends to operate at higher frequencies. Higher frequencies tend to get absorbed fairly quickly by any obstacle in their path. Infrared is line of sight communication. If you put anything in the path of an infrared signal, it stops. Microwaves are running in the gigahertz band as well. They're affected, especially by rain. Fibre optics, they do have attenuation. Depends on the mode. Single mode fibres have very low attenuation. Stepped index fibres, multi-mode fibres have a lot higher attenuation. Crosstalk. When I was talking about the various cables, these two Cat6 cables, that's unshielded. Crosstalk is if the signal in that wire produces an electrical interference or a magnetic field around it, which then interferes with this one. This one interferes with that one interferes with this one. That's what crosstalk is. The degree of twist on each of these cables is different to minimise crosstalk. The other way you can really get rid of it is to go to a multi-core, multi-shielded cable and shield each individual cable inside its own insulator. Crosstalk. Cable. Definitely affected. Wireless tends to be transmitted. If you're looking at wireless radio, AM, you can get signals transmitting, or you can pick up another radio station if there's 2 stations that are too close together, but not as much. Wireless Digital modulation generally is unaffected by crosstalk. Digital, no. Infrared, absolutely. It all transmits on the one frequency. So if you've got two remotes working, then they both basically control each other's machine. Microwaves are affected by crosstalk, but being mainly digital communication, not so much. Fibre optics doesn't worry them. Every fibre's inside its own shield. Amplification. Digital is great because if a signal degrades, attenuates, from 100% strength down to 40% strength, when it gets to a repeater station, the repeater station says that was the original digital signal, throws away the original, creates a brand new digital signal and sends that down the line. So it gets to the other end perfectly. What was sent in is what comes out the other end more often than not. If it doesn't, there's error checking methods that are built in digital transmission to throw it away, ask the sender for another copy of the information again. It only takes a fraction of a second to get here from America. So that's digital. Amplification, however, in an analog signal, there's the signal to noise ratio we spoke about. So here's our signal with the noise. It comes down like that. When it gets amplified, the noise becomes larger. Here it's 30% of the height, there it's 30% of the height. Then it gets amplified more. So with analog signals, you want to amplify them as minimally as possible, because every time you amplify an analog signal, you have the effect of also amplifying the noise and the error within it. So amplification. Cable is massively affected by amplifier noise. Wireless. Digital. No. AM and FM. Yes. Infrared. Doesn't exist. There is no such thing as an infrared amplifier. I'm going to put a question mark. Microwave. If it's digital, no. If it's analog, yes. Fibre optics, not affected. It's looking like the world should be running on fibre optics, but of course there are problems with fibre optics as well. Cost, availability, portability. I'd like you to connect your mobile phone to a fibre optic cable and walk around Sydney with it. Quantisation errors. Now we're getting into digital. Cable doesn't have it, unless you're transmitting digital signals down the hybrid coax cable that goes in most houses now with the NBN. Jitter and timing's out? Definitely not for cable transmission, old school electrical transmission. It's an issue, but it's an issue across the board. Wireless, same thing. If it's digital, they affect it, analog it doesn't. Infrared sends pulse modulation out, but it's incredibly low cost, low risk, short range transmission. Microwaves, analog doesn't matter, digital does, fibre optic, all of those cause errors. So there's your comparison of your various transmission media.